Innovation is the practical implementation of ideas that result in the introduction of new goods or services or improvement in offering goods or services to make our life easier. Today we are introducing an Alexa door closer, which is an innovation of the hydraulic door closer, which is a device used to close the door automatically after anybody getting in, a private business, store, agency. Not everybody cares about the door being closed or opened, but the need for this device is to save energy. If the place has an AC that is working, it will be a waste of energy. Temperature, which is required more energy. As much as the hydraulic door closer is important and useful, sometimes it's annoying and not helpful at all, as there has been a problem for people entering or leaving stores while holding stuff in their hands or carrying a huge product. They aren't able to keep holding the door open. When someone tries to innovate a store or an office that has a hydraulic piston attached to the door, it would require someone to be always helping to keep the door open, to have them get the building materials and the equipment required inside and outside. Even if it's a house and someone comes back home from shopping, holding many bags, having a door that is always closed and resisting his mechanical force by the potential force of the hydraulic piston attached to it, it's very inconvenient. The solution for this is to have a way of keeping the door open when it's pushed open and to be able to close it without going through the hassle of closing it by yourself every time someone pushes it open, by generating a way of communicating with Alexa to give the order for closing the door. In the upcoming slides, there are some explanation procedures for the opening and closing, voice controlling, and the mechanism of this change to clarify how this idea can help everyone.
So the first component needed for our innovation is a torsion spring door closer. The purpose of a torsion spring door closer is that it basically converts doors with hinges to be self-closing, so that a person doesn't need to exert any sort of individual force to manually close a door. Also, this invention prevents the slamming of doors. So the mechanism of the door closer ensures a controlled closure of the door. The door closer also keeps the force and speed of the door closure at a certain level to avoid injury from heavy doors. It also controls the open swing of doors, so a door won't close too fast or too slow, but rather it will close at a controlled speed. Also, there's the added benefit of security. For offices, bedrooms, businesses, it's always good to have a door that remains closed, so this invention is good in that aspect. So the components of a torsion door closer are the torsion spring, screws, the closing arm, and a slide plate. The spring is an essential component of the torsion spring door closer. It's twisted from one end to store and release rotational energy to the other end. The screws are bolted into the door and provide support for the door closer. The closing arm, which was shown earlier as well, is basically the connection between the door closer and the slide plate. And then the slide plate is screwed onto the door and is connected to the closing arm. So here is a depiction of the door closer. This is the closing arm, which is connected to this main body right here. This is the slide plate, which is connected to the closing arm and is connected to the door as well. So it maintains that connection between the door closer and the door. And then this rod right here is inputted here. And basically this is how you can adjust the tension and the how fast or slow the door closes. And here's a video of how exactly this door closer operates. So when the door is opened, you can see that it closes automatically without any sort of manual intervention.
Next, we'll be discussing the second component needed for innovation, which is a latching solenoid. What is a latching solenoid? A latching solenoid is an electromagnetic device that uses an electrical current pulse or permanent magnets to maintain a set position without the use of constant power. Here you can see an image of a latching solenoid. Now, how does it work and how does it deactivate? The permanent magnets of the latching solenoid allows there to be no current drain on the power supply, keeping it operational. To deactivate it, a current in the opposite direction would be applied to repel the actuation current of the plunger. Next is the specs of the latching solenoid. There are 4 major specs of the latching solenoid, which include the plunger, permanent magnets, coil, and spring. The plunger is the part of the solenoid that moves and transfers linear motion from the solenoid to mental control. The magnets are used to hold a predetermined position without the application of electrical current on a continuous basis. The coil works in connection with the magnets because when the coil receives a current, it sends a magnetic flux to the magnets. And lastly, the spring allows the plunger to extend and retract. Here you can see an image of the latching solenoid specs.
Today I'm going to be talking about our idea for the group project, which was an Alexa integrated door closer. Basically, what it has 4 main components, and these components are the Alexa smart plug, the latching solenoid, the torsion spring door closer, and lastly the slotted door stop. The first component, how the Alexa plug works, is Alexa is communicating with the Wi-Fi, and the plug is also communicating with the Wi-Fi, so Alexa controls the plug. The plug has 2 functions. It can either be on or off, and it allows current to pass through it. So if I say Alexa, turn a certain appliance on, what it's going to do is this little blue indicator light is going to pop up, and it's going to let current flow through and turn on whatever appliance it's connected to. One example of this is in my room I have an Alexa smart plug, and when I say Alexa, turn on my air conditioner, what happens is the blue indicator light goes on and my air conditioner turns on. When I say Alexa, turn off my air conditioner, then the current is cut from the plug, and once the current is cut from the plug, my air conditioner turns off, and that's all controlled via my voice. So I think it's pretty cool. The next component is known as the latching solenoid. Just the basics of what a solenoid is it is just a coil of wire, and whenever you send in alternating currents inside of a coil of wire, what happens is a magnetic field is going to be generated, and that's a corollary to Faraday's law of electromagnetic induction. This is going to produce a magnetic field, which is going to be similar to that of a bar magnet. It's going to have a north side, and it's also going to have a south side. So if we look at what's going on with the solenoid, which has been sectioned or cut down the middle over here, this is the solenoid in the latched position. What they basically do is they wound wire around a plunger, also known as an armature, which moves back and forth. And when they introduce current into the system, a magnetic field is generated. We get a north and a south. And here are the field lines over here. So once we get those field lines, what's going to happen is, because the armature is going to be made of some kind of ferrous material, it's going to have free electrons. And these free electrons, they're going to have electron spins. The spins are on the electrons in the ferrous material are going to want to line up with the field lines. So the plunger is actually going to retract when I introduce currents, and when I cut the current from the wall going to the solenoid, what's going to happen is the armature is going to go back to its original position by the spring force, which is right here. So when I introduce current again, it's going to retract, and when I cut the currents, it's going to return to its original position. The idea of the solenoid is just basically to convert electrical energy to mechanical energy. And depicted here is an actual solenoid. Okay, so next we're going to talk about the torsion spring door closer. Shown over here is a wound up piece of metal. And if we wound this piece of metal tightly, what it's going to want to do is unwind itself in the opposite direction. Shown there. And that's the basic idea behind what the torsion spring door closer is doing. We have a shaft here, which we screw into one of these holes, and we tension the torsion spring. And what it's going to do is it's going to want to kick back in the other direction. We attach it to the door with 4 screws. And once we attach it to the door, this big metal arm rides on a slot which is on the door. When you open the door, it puts a lot of tension on the torsion spring, and as soon as you release the door is going to close shut by this spring force. This last component is a slotted door stop. It's just a door stop with a slot over here, and it has four holes for screws. This goes on the bottom left side of your door. To give you guys a better idea, I have a full picture of a SolidWorks assembly where I basically put everything together. Shown here is the torsion spring door closer. Shown right here is the slotted door stop. Shown over here is the latching solenoid, and this is a little slot that metal arm that I was talking about rides on the door. So once we open the door, what's going to happen is this slotted door stop is going to come into contact with the plunger on the solenoid, and once we open the door a little more, the plunger is going to ride on this latching door stop, and then eventually it's going to fall into the slot, and it's going to be pressed in there, and that's going to hold the door open. This solenoid is going to be attached to an Alexa plug. So when you say, Alexa, close my door, what's going to happen is current is going to be fed into the solenoid. Once current is fed into the solenoid, the plunger is going to retract. Once the plunger retracts, then it's going to come out the slot of the door, and the door will close due to the wound up torsion spring. To give you guys a better idea of how all our parts are working together, we have here a typical opening and closing cycle of the Alexa integrated door closer. So in this simulation, we see that the torsion spring door closer, which has an arm, is riding along this slot. The slot is attached to the door. Here we see the slotted door stop, and over here is the solenoid, which is anchored to the wall. We see that the solenoid plunger is coming into contact with the slotted door stop, and it's riding along the slot until the end where it gets fitted inside of the slot, and the door is in the open position at this point. I'll play the simulation one more time without interruption. Great, so that is a typical opening cycle, and the door is stuck in the open position at this point. When we say the words Alexa, close the door, what's going to happen is current's going to flow through the Alexa plug. Once current flows through the Alexa plug, the solenoid plunger is going to retract, and the door is going to close due to the energy stored in the torsion spring. And that concludes our presentation. Thank you, everyone.